In this video, I'm going to go over how to create the work coordinate system and the stock setup for the 3 plates that you need to machine. I have them placed in an assembly with the fixture, and we're going to first get them constrained. Before I do that, I just want to look at each side, and you can see that this face has features that we need to machine, so this face definitely needs to be facing upward. The other two do not have any such features, so it doesn't matter which side is down and which side is up. So I'm just going to hit C for constrain and select the piece and constrain it here. You're provided a 9-inch square piece of 1/4-inch aluminum, and so all of this material needs to get fit onto an area that is no larger than 9 inches by 9 inches. So I'm just going to move the pieces around and do some measurements after I get them. Maybe I could orient the pieces like this so they take up less space. One thing I want to measure is hit M, measure from this edge to like here. You can see that that is still under 9 inches. It looks like I'm good. One thing I want to do is make sure that there is enough space between the parts to fit some screws to hold down the part. You can see I could hold it down here, maybe here, and so there are some places between the parts that I can put screws to hold the parts down. And once I get them in place, what I'm going to do is just ground them. And I am actually going to make sure that the fixture plate is grounded. It looks like I've already done that before the video was started. One thing I also like to do is just change the color of the parts just so that they're not the same aluminum color that they are in as a fixture plate. So I'm just going to change that color. Really doesn't matter. I like cyan, but you can choose something else. I would recommend that you don't choose a transparent color. Now that I have them placed, I'm going to go to CAM and go to Setup. And with the setup, I need to tell Inventor what are the models. And so these 3 parts are the models, and then this part is the fixture. And for the stock, I'm just going to go a relative size box, and I'm just going to add a little bit of material to each in each direction. Notice that the material is the same thickness as the part, but it is no taller. One thing that you also need to do is set up the work coordinate system such that the back rear corner is the origin right there with the Z pointing up and the X pointing along this axis here where my cursor is. And so to do that, we can go select the Z axis / plane, X axis, and right now the work coordinate system is oriented properly, but if it is not, we would need to choose the Z axis to be perpendicular to this plane. And so notice how it's highlighted. You would just click here so that it is perpendicular to the plane, and then the X axis would need to be along this line here. It already is, and so we're okay there, but if it weren't, you need to orient it properly. And then finally, you can just go to selected point for the location of the work coordinate system and make sure it is on the fixture plate, not on the stock or not on the model. And so that is where the origin is for this. So now that we have the location of the work coordinate system and the stock location, we can hit OK. And now what we need to do is do the boring operation. Basically, we're going to bore some holes so we can drill through and hold these parts down. So what I'm going to do is go to the CAM tab. I'm going to go to bore and select some edges, basically some holes in the fixture plate that I need to match up to. I'm just going to get a handful that do not interfere with the parts and that are far enough away from the perimeter of the parts so that I don't hit it with the end mill when I'm coming around and machining out the part. Looks like these are some reasonable parts that surround or reasonable selections that surround the parts that could hold down the fixture plate. Now that I have those, the tool that I want to use is a 3/16 inch flat end mill from the Haas VF3 library. That is tool number 3. We'll select that. Other things are the heights. It wants to go to the bottom of the fixture plate. We do not want to do that. So the top height is actually the model top, and the bottom height is the model bottom, or it could be the stock bottom. Those are the same thing. And we want to stay above the bottom of the part by about 0.03 of an inch because we want to not touch the fixture plate. Other things I want to do is change the ramp angle. Notice how it's really steep. If you click this button, we can define the ramp angle instead of the pitch. And the 2 degrees is fine. If you can go 3 degrees, but basically we have a much finer pitch as we go down and wind down and machine this. Finally, we need to change the amount of stock to leave. This is basically only going to make a hole this size. That's a tapped hole for 1/4-20. We need a clearance hole, and so we need a much larger hole. And I'm going to, if you go -0.04 or 0.40 of an inch, that will give us the hole size that we need to fit the screw through the stock material that we can hold it down. Once we have that, we are pretty well set for the boring operation. So in short, what we would do is clamp the stock material down. We would run this setup and it would bore all those holes. Then we would put screws in all of those holes and then machine out the rest of the part. So now we're ready to do the tool pass for the rest of the part. And what I recommend you do is just right click here and duplicate this setup, because we're going to use the same stock, same work coordinate system. We'll just now call this setup 2. And we're going to get rid of this, and we're good to go for the tool pass for setup 2. I will do that in a subsequent video.